Good morning, students. So far we have studied about different chromatographic techniques, the classification, then about paper chromatography and its classifications. Now we are going to study a new technique that is called thin layer chromatography. So it is very similar to the paper chromatography, but the difference is that in the case of paper chromatography, we have used different qualities of filter papers, but here we are using a thin layer of adsorbent material. The thin layer can be pasted on any solid support such as plastic, glass or any material like that. So we are making a thin slide or a thin layer of adsorbent on a surface, and on this surface the separation is taking place. So now we can look what is meant by thin layer chromatography. So thin layer chromatography is actually was developed to use in the separation of plant pigments. As I said, that means the chromatographic technique was firstly introduced to separate the plant pigments. So here also the thin layer chromatography was first used for the separation of plant pigments. Okay. So, in the case of thin layer chromatography, it is more applicable to non-volatile mixtures. That means the mixtures which can retain on a surface. Okay. So, like the other chromatographic techniques, thin layer chromatography depends on the separation principle. That is, the separation lies on the relative affinity of compound towards the two phases. That is the stationary phase and also the mobile phase. In thin layer chromatography, we are using a thin uniform layer of adsorbent. The adsorbent can be silica gel or an alumina coated on piece of glasses, metal or rigid plastic. So in the case of thin layer chromatography, the stationary phase can be any adsorbing medium such as silica gel, alumina, case agar, cellulose, etc. And these are actually first of all made into a slurry, and we are applying these material on the surface of glass or plastic. Okay. Then there are so many other compounds which can be used as the adsorbing material. But silica is the most common material. Silica is slightly acidic, but in the case of alumina, it is slightly basic. So we can select the adsorbing medium according to the component's polarity. Okay. So the silica gel is slightly acidic and the alumina is slightly basic. And when we are looking at the adsorbing material, why they are used as adsorbing material or why they are used for the separation chromatography technique means the silica gel and the alumina particles contains hydroxyl groups on their surface. That is, hydroxyl group means they contains OH group on their surface. So these OH groups can easily form hydrogen bonds with the polar molecules such as organic compounds. So the organic compounds are normally known as polar compounds. So the polar compounds can easily form hydrogen bonds with the adsorbing material. So depending on the strength of the hydrogen bond, we can decide the separation type or we can have the separation done. There are certain other adsorbing materials such as polyamides, magnesium silicate, calcium silicate, activated charcoal, modified cellulose, with ion exchange properties, and various forms of organic gels such as Cephadex, Biogel, etc. So we can have a large number of adsorbing materials for the thin layer chromatography, and the most common and the cheap one is the silica gel, and it is very easy to handle and apply. So we are preferring silica gel over all the other adsorbing materials. And normally we are preferring the glass plate. And the glass plate can be in the size of a microscopic slide. Okay, that means very thin or very small glass plate is required for the separation of components. So next is the mobile phase. So in chromatographic technique, we have two phases. One is the stationary phase. In TLC, that is thin layer chromatography, we are using silica gel as the adsorbing material of the stationary phase, and the mobile phase can be any suitable solvent depending on the polarity, and we can arrange the solvents or the mobile phase which are used in the thin layer chromatography as per their polarity, and and this arrangement or this series is known as Iliotropic Series. That means they are all known as eluting solvents or eluents. So the name Iliotropic Series. Okay, so the Iliotropic Series is the arrangement of solvents used in thin layer chromatography according to their polarity. So any solvent from this list can be selected for the thin layer chromatography depending upon the polarity. Then principle. Principle means, as I said, the main principle is the adsorption. That is the selective adsorption of a component on the surface of the adsorbing medium. It is normally similar to the paper chromatography except that it is having very thin layer of adsorbing material such as alumina, silica, magnesium oxide, etc. And the substrate is spreaded on a surface instead of paper. The layer of one of these oxides is made from a slurry of powder in a suitable inert solvent. That means, first of all, we are making the adsorbing material into a slurry. Slurry means a paste. Okay, and this paste is evenly spread over a flat surface mechanically. And now we have automated thin layer chromatography preparation apparatus. That means we can just mix the slurry and put it on a applying apparatus, and it will apply on the surface evenly. Normally we are doing it in mechanical manner. That means we are applying by glass rods or by applying by hand. Okay. So the advantage of using inert substance instead of paper is that more effective developing reagents such as strong acids can be used to detect the compounds without destroying the substrate. Normally it is useful for the separation and analysis of high molecular weight biochemical compounds. A variety of mixtures such as amino acids, dyes, food colorings, drugs, sugars, natural products and insecticides may be separated and identified. So now how we are doing the thin layer chromatographic experiment. So as I said, first of all we will prepare the thin layer chromatographic plate, that is TLC plate. For that, first of all we will make the slurry of the adsorbing material and will spread on the surface, and this adsorbent placed on the glass plate is oven dried. That is, we are drying it in a hot air oven, and after some time, once we are assuring the dryness of the plate, similar to the paper chromatography, we are drawing a line by a pencil at the bottom of the glass plate about 1 centimeter above from the bottom edge, and on this line we are putting the sample. That means we are placing the sample as simple dots with the help of capillary tube. Okay, then again air drying, and we are just placing it in a beaker or a chamber containing suitable mobile phase. And depending on the capillary action, that means the solvent along with the components move upward in the adsorbing medium, and depending on the rate of adsorption or depending on the force of attraction between the stationary phase and the mobile phase, the components are separated as different spores. If the materials are colored, then we will have colored spores. If they are non-colored, we can make them colored by using suitable coloring agent, or we can visualize them in UV light chamber. So this is the initial stage of the thin layer chromatography. That means this is a thin layer plate. We are drawing a line at the bottom, then making a dot, and in this dot we are placing the mixture to be separated, and then we are placing this in the beaker having the mobile phase, that is a solvent, then covering the beaker or covering the chamber by a lid. Then after some time, what happens means, this was the first stage, and after some time the solvent moves upward and it will take the component along with it. This was the mixture. Now it is separated into two components, one red spot and a blue spot. We are assuming that these components are colored. Then after some time, the solvent will reach a particular height and component A and B will also be appearing in a particular distance. And we are measuring the distance traveled by the solvent front and also the distance traveled by the components. Then we will find out which components are there in the mixture by the help of RF values. That is the distance traveled by the component divided by distance traveled by the solvent front. It is very much similar to the paper chromatography. So in a real experiment, we will get something like this. You can see can you see the beaker? That means here we are placing the solvent. This is the thin layer, and normally, even though we are saying that we are getting some spots, often it is like in the tailed spot. That means it will be, that is here we are having the solvent with it. So depending on the adsorptive force, there will be a tail for each spot. So we can have a colored spot or a tailed spot on the glass plate. Now we can visualize how this happens. That means how we can have the assembly. So this is the actual assembly or a simple assembly by which we can perform the thin layer chromatography. That means this is actually a measuring jar. Measuring jar means it is very, very small assembly. That means a very small bottle. And inside this bottle, we can have the separation process very effectively. Okay. That means this is the pencil drawn line and this is the spot we are placing, that is the of the mixture. Then this is the mobile phase, that is a solvent, and now this will move upwards, and since this is closed and we can have a closed environment, that is there is no other interaction of the environment, then this will move upwards and we can have the separation done. Okay. Now, how we are performing or how we are measuring the RF values. As in the case of paper chromatography, the RF values are measured by considering the distance traveled by the solvent and also the distance traveled by various dyes or various components. Okay, so this is the baseline and this is a different component separated, and this line at the top is the distance traveled by the solvent. So the RF values can be calculated. RF is equal to distance traveled by the compound divided by distance traveled by the solvent front. So this is the thin layer chromatographic technique. Okay. So it is mainly used for the separation, purification and identification of organic compounds. So that is the thin layer chromatography, which is very much similar to the paper chromatography.